Welcome geometry to the video for chapter 12, day number 4. It's about tangent lines. Hey, remember what tangent lines mean. A tangent line is only going to intersect the circle at exactly one point. That point is called the point of tangency. Okay? The one way to check if something is a tangent line is by this second bullet point. Okay, so put maybe a star by this. Okay, a line is tangent to a circle if and only if it is perpendicular. That means 90 degrees. To the radius. Okay, if it's perpendicular to the radius, then it's a tangent line. So this line, it appears that the only spot it's going to hit the circle is point A. Since we draw this radius in, since it's perpendicular, we know that it is a tangent line. So the first couple questions are just going to ask that. So we want to see whether or not that's a right angle. Okay? Here's the radius. We want to see if it's perpendicular to this line AB. Okay, we don't know if it is. We're going to check. Okay, we want to see if that's a right angle. The way we check is with Pythagorean theorem. If 8 squared plus 15 squared equals 17 squared. If that's true, then yeah, it's a tangent line because that's a perpendicular or a 90-degree angle. So we don't know. I'm just going to put a question mark there for now. We're just going to check this. This would be 64 plus 225. We need to see if that equals 17 squared, which is 289. And if you add 64 and 225 this time, you do. So this question mark. We do get that 289 equals 289. So this one, the answer is yes. Okay, AB must be a tangent line. Okay, second one, same idea. We want to know, is this a right angle? This radius, we want to know if it's perpendicular to this line. Okay. One tricky thing about this, the hypotenuse here, okay, if this is 5, okay, and this is a radius, that means this much is 11, we have to use 5 plus 11, which is 16 right there. So we're using the radius of 16, the hypotenuse of 16. So we're using 11 squared and 14 squared as the legs, but the hypotenuse, we want to see if this is equal, we're using 16 squared. Okay, so 5 plus 11 right there. 121 plus 196, we're going to see if that equals 256. We don't know, we want to check. And this is not true. We have 317, which does not equal 256. So this is not a tangent line. So if you get a question about is it or is it not a tangent line, you're going to use Pythagorean theorem to check for that. Okay, then there's just some problems that are used going the other direction. So a lot of Pythagorean theorem if you're looking at tangent lines. Okay, now they're just saying find x. So again, we're looking for that side. We know that we're looking for this side right here, and we know that that's a leg. We know that that's a hypotenuse. So this is x this time. So we know that this is a 90-degree angle because they're saying it is a tangent now. So my legs are 7 and 19. My hypotenuse is x. So 7 squared plus 19 squared equals x squared, and we're just going to solve that. Okay, so when you're looking at that, 7 squared is 49. 19 squared is 381. Sorry, 361. And then that's going to give you 410 when you add those together. So 410 is equal to x squared. We take the square root of both sides, and we get a decimal, and that's fine. 20.2 is going to be x. We'll just say nearest tenth is good enough. Okay. Number 4 is going to be very similar, except for it's that one where you have to be careful about your hypotenuse and how long that actually is. Okay, we know this is a right angle. This is our hypotenuse, okay, but this is 7 right here. This is 11 right here. So we need to add those together and get 18. Okay, 18 is the total length of that hypotenuse. So that's the hypotenuse. My legs are x and 11. So x squared plus 11 squared equals 18 squared. And we're just going to solve that. So we have 121. Oops, that's not where that goes, though. We have x squared plus 121. Equal to 324. We're going to subtract 121 from both sides. X squared is now equal to 203. We're taking the square root of that. Okay, the square root of 203 looks like 14.2. Okay, same idea with number 5. Okay, this one's a little bit tricky though, because you're looking for x, which is only this piece. It's kind of a misleading picture. You're only looking for this much of the hypotenuse. Okay, so we know that that this part is going to be 10 because this other radius is 10. What the maybe easiest thing to do right now is just come up with a new letter for this one. Okay, we're just going to call this y, and we can solve for y right away. All right, so that's going to be our hypotenuse. So we can solve for y, and then we'll talk about how getting x is one step different. We have 10 squared plus 24 squared equal to y squared. This is actually a difference of square, or a Pythagorean triple. So we're going to be able to get a number that's not a decimal. So this is 10 squared plus 576 equal to y squared. So this is 676 equal to y squared. So y is 26. Okay, but that's not what they want. Okay, 26 is this entire distance now. Okay, which means that this green piece has to be 16. Okay, we know the radius is 10, and we know that the radius plus the green piece that we want need to make 26. So x is actually 16 for this one. Okay, kind of tricky. Be really careful when part of the hypotenuse is hanging off the circle like that. Okay. Number 6 has another little trick to it. Okay, we're gonna find x, which is this side. Okay, this side right here is 11 plus 11. So this side right here is 22. Okay, so that's gonna be what we'll go with for that side. We have x squared plus 22 squared equals 25 squared. Okay, this is x squared plus 484 equal to 625. Subtract both sides by 484, and we get 141. The square root of that is our answer. That's 11.9. The square root of 141, 11.9. Okay, same exact trick for number 7. Number 7. Same, very similar picture. Okay, we want that hypotenuse this time of x. So this is our right angle. We know that one of our sides is 6.4. The other side is 3.5 plus 3.5, so this is 7. Okay, 3.5 times 3 or times 2. So we're going to do 6.4 squared plus 7 squared equals our x squared. So if you do 7 squared and 6.4 squared together, you get 89.96, and we're going to take the square root of that, and we get 9.5. All right, same or kind of a similar trick that we did back on number 5 will be needed for this last one on this page. Okay, so I know that 7 squared, okay, plus this squared equals 125. But they're asking for just, or equals 25 squared. So what we have here is just the radius is what they're looking for. Okay, what we're going to find in this step is actually the diameter. So again, let's just come up with a letter for it. Let's just call this whole thing y. So we can solve 7 squared plus y squared equals 25 squared. Once we know what y is, we're just going to cut it in half. And that will give us x. That'll give us the radius. So we have 49 plus y squared equals 625, which means that when we subtract 49, y squared is going to equal 576, and that's a perfect square. If you take the square root of that, that's 24. Okay, but that's the diameter. This question is ultimately asking for the radius, which is half that length. All right, last page here. There's a number 9. It's going to be similar. Okay, this one's even a little bit tougher. So if this is x, I know that this part is x as well. So if I want the entire distance right here, a lot of people will do this part wrong. This is just x plus 10. That's all that needs to go right there. So again, Pythagorean theorem is usually what you're going to use when you're talking about tangents. All right, so when we're looking at this one, we're in the middle of that Pythagorean theorem step, but making sure that we use that green piece of that x plus 10 quantity squared. So this one is going to have a little bit of a trick to it with the algebra. So we have our x squared, that's one of our sides, plus 20 squared is our other leg, this one. Okay, the hypotenuse is parentheses x plus 10 squared. That's a little bit tricky. So over here we have x squared plus 400 equal to, here what we're really doing is x plus 10 twice in a row. Okay, what's going to happen with that is FOIL. So this side isn't changing yet. Okay, we're going to FOIL this side. First times first is x squared. The outsides are x times 10. The insides are x times 10 as well. So that's 10x plus 10x. And then the last are 10 times 10, which is 100. So x squared plus 400 on this side is equal to x squared plus 20x plus 100 on the other side. Okay, this looks more complicated than it is at this point. Once you get x squareds, you have to start getting worried about maybe doing factoring your quadratic formula. But the x squareds are just going to cancel. When you subtract x squared from both sides, those are going to be gone. Okay, and then we're just going to solve it the rest of the way. So move 100 over. Okay, what we have is, I'm going to write a different color here. What we have is 300 equal to 20x. When you divide both sides by 20, we get our final answer of 15. Okay, the hard part up there was that green step. Realizing that hypotenuse is really x plus 10. All right, a couple other things about tangent lines and their properties. So if there's two tangent lines, okay, but they come from the same point on the outside, they're going to have to be congruent. This piece will have to equal this piece if there's two tangent lines, okay? And then if you have a circle inside of any shape, okay, all these are going to be tangent lines. So this would be a tangent line, and so would this, and these would be congruent, okay? This would be a tangent line, and this would be a tangent line. Since they both come from B, they're going to be congruent, and then both of these lines coming out of C will be congruent. So those will be the same length. Okay, so there's going to probably be some kind of perimeter problem that would come with that. So just a couple more properties for you to know. It's a lot of setting stuff equal when it comes to this. So maybe not as much Pythagorean theorem anymore, but setting something equal to something else. Okay, number 10, find x is the directions. Since these lines both, we're assuming that segments that appear to be tangent are tangent. So I don't have to check if they are. Okay, but I do know that these tangent lines are congruent because they both are coming from the same outside point, which is B. So 5x plus 23 equals 8x minus 19. Subtract 5x from both sides and get 3x on the right. Add 19 to both sides and get 42 on the left. Divide by 3. 14 is going to be x. Okay, same exact picture for number 11. These two pieces have to be congruent because they both are tangent lines that have an outside point of Q. 14x minus 13 can then be set equal to 8x plus 5. I'm going to subtract both sides by 8x and get 6x on the left. Add 13 to both sides and get 18, and then divide by 6. X is 3. Okay, looking at this one, it looks a little bit more complicated. They want SV, okay, which is just something a little tricky. But what we can start with is finding out how long or what x is. So SV is this. So we're going to eventually come back and get this. This is like our question mark that we got to come back and figure out. Okay, well, if I can figure out how long this is, I can use Pythagorean theorem to answer that question. So I can figure out how long the green segment is because it's congruent to this green segment. So I can set those equal. 10x minus 41 equals 4x plus 7. Okay, this leads you to 6x equal to 48, which leads you that x equals 8. Okay, not an answer to the question. They want the blue line, and we don't have that yet. Okay, but what we can get now is how long ST is. So we can put an 8 in here. That's 80 minus 41, 8 times 10. So ST is equal to 39. So I know that this is 39, okay? And now I can use 39 squared and 17 squared to figure out that blue line. So the final answer, okay, let's just call this like y, okay? We're going to get y squared by setting it equal to y squared equals 17 squared plus 39 squared, okay? This gives you, when you go in your calculator, this 810, 17 squared plus 39 squared. We'll take the square root of both sides, and we get 42.5. So that was a 2-part question. Okay, and then these ones, like I was saying earlier, are perimeter questions. Okay, last 2 for this video. Here's what we know. This piece has to equal this piece, so this would be a 16. Okay, this piece has to equal this piece, so this was a 9.5, so is this. And then these 2 pieces have to be the same. This 11 has to be the same as this, so that's an 11. So for this, the perimeter, we're just going to add all of that up. So the perimeter is 11 plus 11 plus 16 plus 16 plus 9.5 plus 9.5. Okay, long story short, that comes out to 73. We don't have units, so just 73. Okay, this one just says it makes you work for it a little bit more. So this one is 23, which means this much of it is 23. Okay, which means if this piece and the blue piece have to make 37.5, that means this one has to be 14.5, which means this has to be 14.5. If that's 27.1, so is this 27.1, and then if that's 27.1 and they need to make 52.5, that tells me this has to be 25.4. So that's what we're going to add up. We're going to add up all those all the way around. I'm not going to copy all of that in, but 23 plus 23 plus 14.5 all the way around. Okay, adding up all 8 of those numbers, we get 180. And that's it for the video for lesson 4. Now you can do the lesson 4 worksheet. Thanks for watching.